Hello and welcome to this Haas tip of the day. Now today's tip is all about our tool offset page and probing our tools. In fact, right now while we're filming this intro, my machine is over there touching off all of my tools. Now all I did was answer a few questions, estimate some tool lengths, and press cycle start. Now if you don't have a probing system on your machine, stick around because we're going to be slowing things down a bit and covering our tool offset page as well. We've got a bunch of tips that you don't want to miss. Everybody is talking about automation these days, and when it comes to machining, automation starts with our probing system. Now, if you've heard that line before, you've probably seen our spindle probe video where we show you how to set a work offset with your spindle probe. If you haven't seen that video, check it out. This video is all about our tool offset page and setting our tool offsets with our probing system. Now I think the easiest way to get to our probing cycles is from our offset page while in memory mode. If you go to your offset page and you see the work offsets instead of the tool offsets, just press the F4 key to toggle over. From here, if I was going to give you the short version of how to probe a tool, I would just tell you to answer all the questions, fill in every blank all the way across for that tool. Then, with the probe type highlighted, press the tool offset measure key. Then follow the on-screen instructions to probe that tool. So, you're going to fill in the blanks, press tool offset measure, and then follow the instructions. That's pretty much it. That's probing your tool. It is just that simple once you have an understanding of what your tool offset columns do. And that's what we're going to do right now. We're going to give you an understanding of what each of those tool offset columns can do for you. We're just going to give you a little summary. This first column is our tool offset number. Typically, we'll use offset 1 for tool 1, offset 2 for tool 2. Now, I've got a shell mill loaded up in the machine as tool number 1. So for us right now, this entire row, offset 1, is now going to relate to tool 1, my 3-inch shell mill. These next two columns are our length geometry and length wear columns. Now these two columns are tied to the G43H values from within our programs. These are our tool length offsets, and they're going to be set by our probe. If I command a G43H1 from within a program for tool 1, it's going to be referencing these two columns for row 1, offset 1. If I command a G43H2 from within a program for tool 2, typically, it's going to be referencing these two columns that are set by our probe for offset 2. These next two columns are our diameter geometry and our diameter wear. These columns are used for cutter compensation, and again, they're going to be set by our probing system. If I command a G41D01 from within a program, you're going to be referencing these two columns for offset 1. G41D2, you're going to be referencing these columns for offset 2. Cutter compensation is a big topic. You can look it up in your mill manual. Again, those values, length geometry and diameter geometry, these are all going to be set by our probe. Next, we've got our coolant position. Now, this column is only going to show up on your machine if you have the P-Cool nozzle, a programmable coolant nozzle. We actually made an entire video on how to set this column, so be sure to check that one out. That column has nothing to do with probing. Well, from here, it looks like we're at the end of our tool offset page, but actually it continues on far to the right. If we were to stretch this column out, it would go all the way to here. To get to those other tool offset page columns, we're going to press the right cursor button, the right arrow. Our flutes column has nothing to do with probing, but it's still a good idea to fill it in every time. Our control can display our actual chip load while running if we've correctly filled in the number of flutes for our tool. Our VPS speeds and feeds library also makes use of this column. Here on our actual diameter column, we're going to enter 3.0 because we've got a 3-inch shell mill. Now this value does not have to be perfect. It's not used for cutter compensation or for any of our probing cycles. This column is primarily used for our surface speed display calculations when the tool is spinning. Next, we come to our tool type. Now, by selecting the tool type that best matches our tool, we're helping the control decide exactly which probing cycle to use. Now, we won't be setting our tool material. This is used with our VPS speeds and feeds library. Our next column, our tool pocket column, is read only. If you've got a side mount tool changer, it's going to show you what pocket that tool is currently in. Next, we've got our tool category. Now, our tool category isn't for probing, but we might need to set it when setting up a tool. With the category column highlighted, if we press the Enter key, that's going to bring us to our tool table. Here's where we can designate our tool as heavy, H, or large, L. Using our right arrow cursor key one more time, we're going to move over to our final tool offset page. Now, this page displays all of our tool probing columns. This is where we're going to probe our tool. If you probe a shell mill or an end mill, the control is going to want to know the approximate length of that tool. That's the distance from the tip of the tool to the tool's gauge line. Now, you know what the tip of the tool is, but where's gauge line? For this approximation, we're just going to use the face of the spindle as our gauge line reference point. So if I pull out my scale and hold it up against my shell mill, I can see that my tool is just about 4 inches long. So we'll enter 4 inches into this approximate length column. If I was going to probe the length of a drill or a tap, some tool that's not a shell mill or an end mill, you could leave this column blank. You really don't need to fill it in. Now in this example, I want the actual diameter of my shell mill probed. So I'm going to fill in my approximate diameter and my edge measure height. It's a 3-inch shell mill, so I'm going to enter in 3-inch for my approximate diameter. And for my edge measure height, I'm going to enter 0.2. This is the distance below the tip of the tool that the tool needs to move when the edge is probed. This is really useful if you've got a tool with a large radius, or even when you're probing the diameter on a chamfer tool. Our tool tolerance column is used for tool breakage and wear detection. Now, we don't want to check to see if our tool is broken. We're actually going to be setting our length and diameters. So we can leave this column blank. Well, now it's time for our last tool probing column, probe type. We're going to pick up the length and diameter of this tool, so we're going to enter 3. Then we're going to follow the on-screen instructions. Press tool offset measure for the automatic probing options. We're going to enter the number 1 to probe the selected tool. And now we're going to close the doors, press cycle start, and probe this tool in MDI. There we go. The machine is moved up and over, and it's going to come down and probe both the length and the diameter of this shell mill. Well, you are now an expert on the Haas tool offset page and are ready to set up some tools. If you'd wanted to set up a drill, then you would have just been sure to select drill as your tool type. You could have left the approximate length and approximate diameter columns blank. And for probe type, we could have chosen number 2, length probing, non-rotating. Now, if you're using a cam system, you often don't have to enter in a tool's diameter. The cam system's taking care of that for us. So you can choose tool type 4, end mill, from your screen, and then when it comes time to probe that tool, we're just going to enter in an approximate length, an approximate diameter, and then for probe type, we're going to select number 1, length probing, rotating. This is just going to set the tool length offset and not pick up the diameter at all. Now's a good time to mention that if you're going to probe your tools, probe all of your tools. You don't want to set some of your tools manually and some with your probing system. You want to set all of your tool and work offsets with your probing system. Now, with all of your tool information set, you can actually have the machine probe all of your tools at once, like I did during the intro to this video. So you fill in all of your information, and then you press tool offset measure, and you select probe all tools. When you do that, the control is going to go ahead and probe all tools that have a probe type selected other than none. If it's set to none, it's not going to probe that tool, when Probe All Tools is selected. Well, that is it for today. We took the long way around probing a tool, but now you know what all of those tool offset columns mean, and you can decide for yourself which ones need to be filled out and which ones you can skip. You might know more about the Haas tool offset page than anyone else in your shop. Now, if you're a programming wonk and you want even more information, check out the bonus content in the YouTube version of this video. We've made a little sheet for you that explains what all of these columns do. I am a Haas Applications Engineer, Mark Terryberry. Thanks for watching this Haas Tip of the Day.